what is the value of resistance when two resistors are connected in? Okay, so if you look here in 16a, so they tell you that the total here is equal to 10 ohms. And they tell you that this one here is 10.2 ohms. But they do not tell you what this one here is. And you're asked to find it. So we know 1 over 10 should equal 1 over x plus 1 over 10.2. Yep. So, using our middle school maths, we can add these fractions to, we can take the 10.2 to the left there. So Andy, we might as well just type that in on the calculator. What is 1 over 10 minus 1 over 10.2?
1 over 510.
Thank you. That is 1 over x. Therefore, x equals 510 ohms. Do you have a Twix every day for breakfast?
Yes.
And your parents would know this?
Yeah.
Would they?
It's okay.
They don't worry about you?
No.
No?
I do not sugar.
Oh, right. Yeah, this is what I mean. They don't worry about you? No.
Why is it served?
Huh?
Does it
Type with this.
Oh, I don't know. It doesn't feel healthy to have Twix every morning for breakfast.
I even drink hot chocolate.
For breakfast? So your breakfast, let me get this straight, is 1 hot chocolate and 1 Twix bar. And what else?
Chocolate Danish.
1 hot chocolate?
Yeah.
1 chocolate Danish?
Believe me, yeah.
Yes, and 1 Twix. I see. And your lunch?
And hot chocolate and croissant, chocolate and Twix.
Chocolate croissant and Twix.
And hot chocolate.
Yes, oh dear. And lunch?
I eat something then chocolate.
Well done.
His size.
Do you know what diabetes is? Yes, alright. How old are you?
18, 19.
I'd say maybe by 21, 22, diabetes.
Oh shit, so I have diabetes.
You do? Type 1? There's 2 types, type 1, type 2. So one of them you're born with, and then the other one you get from eating too much sugar.
Yeah.
No.
It's even
I think
too much or no sugar, so
Type 1 is
should
better.
Should be balanced, yeah.
Type 1 is better.
Type 1 is the one that you're born with.
You can always eat.
Type 2 is the one that you develop when you have too much sugar for too long.
So type 1 is always eat.
No, I don't.
Any it's better.
The sugar.
Yes?
Drink the sugar.
It's not that.
I'm looking at
My
I'm looking at a class of healthy students.
it's good to eat chocolate every day, but a small amount of chocolate because it's good.
Yeah, a small amount of chocolates it's okay. Just maybe not a Twix, a hot chocolate and a chocolate croissant followed with chocolate for lunch, and then I'm sure after your dinner or before bed, yeah, you like to wind down at the end of the day. I'll just have another Twix just to relax.
But they don't have the Oreo thing, the candies there.
Really?
Sometimes.
Oh man, you got issues. You need to be taking him to the gym with you, yeah?
So yeah.
Okay, now B part. Do you have that taken down? Yep. So what is the definition of capacitance? So remember the formula Q equals CV. So C is Q over V. But I think I actually gave you this one from an earlier question, didn't I?
Just answer that is it.
It was 11A, maybe.
Just complete.
Oh, right. So when you have this formula, how would you define capacitance? So you could say, from using this formula, Yeah, but you kind of have to
Charge of
flash.
time.
No, this is true, but you kind of have to flesh it out more in English. So, the capacitance of a capacitor.
We had a little problem with English.
English is a big problem, I know. The capacitance of a capacitor is. The capacitance of a capacitor
Charge.
is.
Come on, native.
How. Yeah, come on, native. Go on, get going. The capacitance of a capacitor is how much charge it can hold per unit volt I forgot how to spell potential, so I'll go with just PD, potential difference. Now I'll try it, hang on, be a good native speaker. P-O-T-E-I, no. Don't confuse me, please, I'm so tired.
Go 10.
10?
10.
No, just give me it's one of these situations where I just need a few seconds of silence, okay? No, silence, few seconds. Potential. I don't think you appreciate how much energy is used teaching and how distracting it is. The capacitance of a capacitor is how much charge it can hold per unit volt potential difference.
If I wrote really short, like charge hold in a capacitor probably go.
That will do.
Short is better.
Yes, short, yeah. Well, your English teacher might not agree. Who's your writing teacher? Connell, yeah. Okay. I don't. What did you come to Ireland for if you hate English? Yeah.
Well, we have such questions where they say state or define.
Yep. Basically, anything that's in this book can be on the exam.
Thought it's about the calculations.
Mostly calculations, though.
So,
You look really tired, Amber.
Yeah.
Why are you so tired?
I didn't sleep last night.
Any special reason?
No, I just went to my friend's house and I came back like.
In other words, you were up all night partying.
No, because no.
Gaming, Facebooking.
Or must with ing.
Can we say that? Yeah, of course.
I think it's an okay term, Facebooking. Now, whether your English teacher will accept it, I don't know.
YouTube.
I don't know if you could say YouTubing. No, I don't think so. Facebooking or Twittering. Or Googling, tweeting, twerking.
Let's get it quick.
Alright, last one now. What value of capacitor will store 250 microjoules when the voltage is 50 volts? Now, do you remember the formula for how much energy is stored in a capacitor? A half CV squared. So we have 250 times 10 to the minus 6 equals a half CV squared. So a little bit of rearranging gives me C equals 2 times 250 times 10 to the minus 6 all over 2,500. Okay, what's that, please?
Sir, will the exam be as hard as the first one?
What do you mean?
The first one we did was very hard and it wasn't enough time.
Let me put it to you like this. If you got these, do you consider these questions hard, easy, or average? Average, then the exam you will find of average difficulty. In fact, some of the questions in the exam, maybe you've seen them before. in this revision book, for example. Possibly. Not all of them.
So it's
Just most of them.
So if
Yeah.
W represents
The energy stored in the capacitor. How many joules of energy is in the capacitor? The work, the energy.
it's similar to kinetic energy.
It is actually, isn't it? It looks like kinetic energy formula,
Yeah.
which is a half mv squared. So maybe that makes it easy to remember then.
No, I mean, is it anything related to it? Is it kinetic energy or it's energy?
I would say if you were to give me, if you said what type, is it more like kinetic or it's more like potential? I'd say it's more like potential because it's the energy stored in the capacitor. You know, it's how much energy it has stored inside of it that it could release as work, you know. A bit like potential energy when you hold it. It has energy stored inside of it because it's above the ground, you know. What's that, Habib? 2 to the 10 minus 7? So 2 to the 10 minus 7 will be 0.2 microfarads, because micro is minus 6. If you want to convert it into micro, actually, in fact, I can actually do it here. 0 and 0 cancels. 25 goes into 258 times. 2 goes into 8 4 times. So actually, was it 0.25?
No, you wrong. 25 to 2500.
Oh, it's 2500, sorry. It's not 8, is it? Rewind. Right. That cancels that. 25 goes into this 10 times.
Yes.
2 goes into 10 5 times. 1 over 5 is 0.2, and then the 10 to the minus 6 is the micro there. Now you don't have to do that. It's fine if you don't. You can give the answer, Habib, as 2 times 10 to the minus 7 farads.
So is this, I always confuse in the units. So is it big?
Yeah, let me actually, you know what? Let me just run through some of the key units, okay? So, the ones we use the most. Milli means 10 to the minus 3. Kilo is 10 to the 3. Centai is 10 to the minus 2. Mega is 10 to the 6. Giga, I don't think we ever had a giga one, did we? No. We had also micro, which is 10 to the minus 6. So for this part of the course, these are the ones we've used so far. Okay? So if you were to see, for example, a number like this, 5 mega whatever, joules, ohms, I'll just call it mega x. You can replace the word mega with 10 to the 6. So 5 times 10 to the 6 x, or whatever the unit is. But suppose it's the other way around, like what we had with Habib there. We had 7 times 10 to the minus, or what was it? 2 times 10 to the minus 7 x, or farads, or whatever it is. And we say, minus 7, I'd like to write that as micros. Okay? So what you can do is you can divide this number by 10 to the minus 6 and then stick a micro in. So when you type that in on your calculator here, you get 0.2 micro. So in other words, well, let me do another example. Let's say I have 5 times 10 to the minus 5, let's say meters, and I'd like to change it into micrometers. So what do? I divide by 10 to the minus 6 and put in micro. And the reason I'm allowed to do that is because what does micro equal? What is micro?
10 to
10 to the minus 6. So it's like this and this cancel. So you haven't changed the number value.
Okay.
So Habib, can you type in this fraction here and tell me what you get? It'd probably be 50 or something, would it? I think so. 10, yeah, I think it'd be 50 micrometers. It is not necessary to do this, but it's nice if you can.
What about if I forget to put a unit?
I will probably take a mark away if you don't put a unit in your answer.
1 mark.
I feel it is important in physics to have the unit. So yes, I'll take away 1 mark if you don't have your unit in. So for example, if the answer was 50 micrometers and you just wrote down 50, I have no idea if you mean meters, micrometers, kilometers, you know. So although the number is right, the unit is not, which is extremely important. So I would take 1 mark away from you for doing this. Okay.
All the answers.
What?
I mean, all.
What?
No, I mean the revision book.
Yeah?
All the answers.